My name is Miguel Ángel Medina Torres, and I am going to explain you the main contents of this poster entitled Learning about Krebs and his Four Metabolic Cycles by using a problem-based learning approach. The list of authors of this work includes two doctors, Ángel Luis García Ponce, Ángel Blanco López, Ana Rodríguez Quesada, José Luis Urdiales, Ignacio Fajardo, Fernanda Suárez, and Francisco José Alonso Carrión. We are a group of professors of the departments of molecular biology and biochemistry and the Department of Didactics of Natural Sciences at the University of Málaga in Spain. This work has been carried out in the context of an educative innovation project entitled Collaborative Learning of Biochemistry based on projects and case and problem solving. In fact, this educative innovation project is the continuation of two other previous ones, in which we have designed and used problem-based learning cases to help our students to study metabolism and its regulation. In the present communication, we show and discuss the results obtained with the application of an extended PBL approach focused on the four metabolic cycles described by the Nobel Prize winner Sir Hans Krebs under a learning contract. The objective of this work have been mainly two. Firstly, to improve the teaching learning process applied to the study of metabolism by using a design-based research methodology, DBR, and a problem-based learning approach, PBL. And second, to change certain attitudes of students, decreasing their competitiveness and increasing their cooperativity by stimulating their engagement with procedures of cooperative study in a class less hierarchical and more horizontal, with the professor in the role of a facilitator or a guide in a flipped classroom. The tools that we have used to fulfill these objectives are the case and the educational research methodology. The case covers systematically the main contents related with the four metabolic cycles described by Sir Hans Krebs, namely the urea cycle, the tricarboxylic acid cycle, the glyoxylate cycle, and the uric acid cycle. The case that we have decided consists of 6 tags related with historical issues regarding the scientific studies by Sir Hans Krebs, 10 tags related with the structures and properties of some molecules of the Krebs cycles and on the topology of these 4 cycles, 21 tags regarding each of the 4 cycles described by Krebs and his collaborators, the regulation of these 4 cycles, and the metabolic integration of these cycles in the context of global metabolism within an individual. And finally, 9 tags regarding the biochemical foundations of clinical cases related with misfunctioning of any of these 4 metabolic cycles. The educational research methodology that we have used to fulfill our aims is that supported by a design-based research. This figure depicts the procedure of a design-based educative research. We start with an implementation of a theoretical background, and we take into account the requirements, and both of them are important for the design of the task. This task, in our case, the problem-based learning case devoted to the four Krebs cycles, should be later on implemented. And once the implementation has been taken into account, an analysis of the results provides information that, on the one hand, have implications for theory. We are able to extract new information, and on the other hand, we obtain also information that is useful to redesign our initial procedure, to change it and to fit better to the special features of the group and of the pedagogical goals. And this kind of cycle, most precisely this kind of spiral cycle, begins and restarts once again, once and once more. The guided tasks included in the case were designed to stimulate the interaction among the members of the different groups of students, to stimulate their cooperative behavior during learning, and to stimulate their critical thinking. Some of these tasks encourage our students to read scientific papers and to use biological databases and online resources of great utility. Taking into account the tools, that is to say, the case and the educational research methodology, we proceed to the implementation of the tasks regarding the teaching learning sequence that is described in this flow chart. A flow chart that we have proved previously in other PBL tasks, such as the PBL that we devoted to the study of glycogen metabolism and its regulation, as described in a recent publication in Biochemistry and Molecular Biology Education. This teaching learning sequence was carried out in the following specific context. First, the study was implemented in the second semester of the academic course 18-19. Second, volunteer participants signed a learning contract. A learning contract is a very useful pedagogical tool. And the number of enrolled volunteers were 13 students enrolled in the metabolic regulation in the metabolic regulation course within the biology degrees, the second course of the biology degree. These 3 students were split in 4 groups. And on the other hand, 47 regulation of metabolism students were enrolled, and they were split in 11 groups. Regulation of metabolism is a subject for students in the second academic year of the degree in biochemistry. Each of the 15 groups freely decided how to organize the work and how to share the tasks. Tutorial sessions were only provided on a student demand basis. And from the beginning of the start of the tasks of each of the group till the end, groups had 2 full months to prepare a final report mentioning the specific work done by each individual. Regarding the teaching learning sequence, the pictures in the figure, we proceed to take some points of observation and taking of data. Before the specific problem case was presented, we carried out for all the students of these 2 courses, not only those finally enrolled in the learning contract, for all the students enrolled or not in the learning contract, we perform a test of previous knowledge of the biochemical grounds of these 4 metabolic cycles described by Sirhan Krebs, and test of previous knowledge of the student regarding the PBL methodology. In the presentation of the problem-based learning case, in the tutoring, the voluntary and on-demand tutoring, in the procedure of implementation of results of different groups, sharing their resolutions in classroom, we carried out observations. And we have, once the informs, the final reports were once the final reports were sent to the teachers, there was another point of intervention in which we carried out post-tests for both the knowledge regarding the biochemistry of the 4 cycles described by Krebs and on PBL methodology. And additionally, we carried out a perception questionnaire. And finally, in this teaching learning sequence, we had 2 points of evaluation and analysis. The evaluation carried out by the teacher of the contents of each of the final reports, and the evaluation carried out by the teacher of the results in the final examination for all the students, both those enrolled in the learning contract and those not enrolled in the learning contract. To make a long history short, we are mentioning only some results. And due to the fact that in this year there were much more biochemistry students enrolled than undergraduate biology students enrolled, although we have analyzed the results of all the groups, here in the poster, for the sake of clarity, we show only results regarding our students in the regulation of metabolism of the biochemistry degree. The main ideas that can be extracted from the analysis of these results are as follows. Most of the students, both enrolled and not enrolled to this activity, declare have not heard of and have never used the PBL approach prior to the course. So this didactic methodology was mostly unknown for our students. Second, pre and post multiple choice tests showed a relevant specific knowledge improvement on the Krebs cycle case. The results are summarized in this figure. Orange rectangles indicate the percentage of right answers in each of the 10 questions when the test was carried out before the implementation of the PBL, and blue rectangles show the level of right answer percentages when the test was carried out at the end of the process. The mean percentage of right answers in the pretest was 19%, and this percentage was increased more than twice, up to 40% in the post-test. Third, the PBL methodology had a real impact not only in the overall knowledge of Krebs metabolic cyclic pathways, but also on the study of the cause of metabolic regulation as a whole for most of the enrolled students in both groups of the biochemistry and biology degrees. Although we do not show these results, the percentage of enrolled students that finally passed the exam was clearly higher than the percentage of those students that had not enrolled in this activity and those that were able to pass the final examinations. And fourth, on the other hand, there was a general student consensus that they improved their learning experience by using this type of teaching learning sequence, in spite of the fact that a major effort and dedication to solve the case should be provided by the students. The biochemistry student perception test contained up to 16 questions, each of which a student could answer by applying a 1 to 4 Likert scale, being 1 the less positive student perception and 4 the most positive student perception. As this figure clearly shows, the mean value of student perception for all the questions was well above 12. Well above 2. Finally, this work was possible thanks to the support of the University of Malaga, providing funds granted to the Educational Innovation Project PIE 1957. And the registration to this international conference, New Perspective in Science Education 10th edition, fully virtual, has received a grant from the first Plan Propio Integral de Docencia from our university. Thank you very much for your attention.